Students, this is lesson U5A06b. By the end of the lesson, you should be able to say, I can apply sine, cosine, tangent to solve for sides if given one side and a trig ratio. So this information was actually given to you in the prior two lessons. Here it is once again. So sine of theta is a ratio between the opposite side to the hypotenuse. Cosine of theta is the ratio of sides between the adjacent to hypotenuse. And lastly, tangent of theta is the ratio of sides between opposite to adjacent. This information is vital to your understanding if we were to build on prior knowledge from similar triangles. So let's take a look at some other types of questions you may encounter involving sine, cosine, and tangent. So here in this case, okay, you're asked to find out what is the side length of AB if given the trig ratio for the second triangle. So this second triangle here is triangle PQR, and you're told cosine of theta is equal to 2/3. Upon close inspection here, you'll notice right now that there are two angles that are corresponding and are congruent. You'll also notice that these angles over here are also right angles, thereby making triangle PQR similar to triangle ABC. If they are indeed similar, then you can also establish that angle A and angle P are going to be the same, that this angle over here must also be theta because this angle over here is called theta. So recognizing this as being the case, okay, and I know that cosine theta is equal to PQ over PR, this is also going to be equal to AB over AC. So because this is the case, okay, and I already know what cosine theta is equal to 2/3, I can then say 2/3 will equal to x over 4 because x is my AB value and AC is 4. And then I can solve for x. I cross multiply, and then I end up with x is equal to 8/3. Pause the video to see if you can apply the concept that was applied in the previous problem to this second question here. Hopefully you guys had some time to think about this. So let's take a look at this example now. I now have sine theta is equal to 7/10. And upon close inspection, again, it's a very similar problem. I know that these two angles are going to be the same, and these two angles are the same. Therefore, I can say that triangle LMN and triangle CAB are going to be similar because of angle-angle theorem. Upon close inspection, okay, I also notice that angle C is going to be equal to angle L, so therefore this angle here must also be theta. So with that in mind, sine theta is equal to 7/10 will also equal to AB over BC. And my goal is to find out what BC is, so therefore I want to make the proper substitution, and I'm going to call BC what it is. It's just BC. And I'm solving for BC, so I'm going to cross multiply, divide by 7. I end up with 50 over 7. Pause the video to see if you can solve this last problem. Hopefully you guys had some time to think about this. Again, a very similar setup. The smaller triangle is going to be similar to the larger triangle because, again, I have two corresponding angles that are congruent, thereby making the two triangles similar because of angle-angle theorem. I can also conclude that angle L is going to be equal to angle J, so therefore angle L is going to equal to angle H because the third angle must be the same if the other two are equal. So angle H will also be called theta. So because angle H is called theta, we can then set up the tangent ratio between the two triangles. I know that tangent theta is equal to 1/2. But I also know that tangent theta, okay, for both triangles will be the same ratio. So therefore I can say Kj over Kl will equal to Ji over Hi. I want to make the appropriate substitutions in place, okay? So I can say that 1/2 is equal to Ji over Hi. And I know what Ji is. Ji is 3, and I don't know what Hi is, so I'm going to cross multiply. Hi, therefore, is equal to 6. My goal, however, is to not find out what Hi is, but instead to find out what Hj is. So therefore, the only way that I can approach this is I'm going to apply the Pythagorean theorem. So I'm going to take hi, which is 6, and ij, which is 3, substitute it in. 6 squared plus 3 squared is equal to hj squared. Hj squared is equal to 45. Therefore, hj is equal to 3 radical 5.